Put it up there.
I could, right? Like a GoPro camera?
Yeah, put it upside down.
That'd be cool, right?
Daddy.
The thing is, it's still, what it still takes me doing is then like uploading the videos every night. Which isn't necessarily the easiest thing because they're like hour-long videos and it takes forever to upload those videos to YouTube. Like it took, those videos that I uploaded to YouTube took me literally, I think like,
No, I
it
know.
took like 8 or 9 hours.
Why?
And no, it
Not longer than
for
that.
making GoPro videos and posting them takes forever.
Because they're high quality.
Because they have to like process and
Hello, Joel and Priscilla. Well, what did we go over? Who can tell me, class?
proving triangle similarity.
Proving similar triangles. We went over
Actually, it's that
proving angle similarity. Why? Okay, so the idea is that if two sets of corresponding angles of two triangles are congruent, then the triangles are similar. How do I know that? If I only have two angles are congruent, right? Usually, by definition, it was 3 angles had to be congruent, right? 3 sets. But how do I know that the third angle is congruent?
So they have to add up to 180.
So they have to add up to 180. So no matter what, this third angle will always be congruent. And then we went over this and we showed that if this angle is congruent, these two angles are congruent because they're vertical angles. Therefore, by the angle-angle similarity postulate, those two triangles are similar. Understood?
Yes.
Very good. All right. Moving forward.
Oh my God.
Mr. Munir, look at his magic trick.
What?
Look at his magic trick. Isn't that amazing? Should make you unsure. Stop. 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 Stop.
Side, angle, dash,
Killers.
That's okay.
But it's theorem 7.1. The other one was postulate 7.1. This is theorem 7.1.
I see.
I see you said it right.
I can see. It's good.
I see you said it right.
If one
Set. If one set of corresponding angles is congruent. This is very improper English, but it's okay. And the two sets of corresponding sides
You want.
and the two sets of corresponding if one set
I know I understand.
one if one I apologize if one
The exact.
if one set and the two sets of corresponding sides touching the angle are congruent, then the triangles are similar. I don't think I write too hard on the board. Just write a regular pressure. If one set of corresponding angles is congruent, and the two sets of corresponding sides touching the angle are congruent, then the triangles are similar. I apologize. The second isn't congruent. The second is similar. Are proportional. Not congruent, proportional. And the triangles are similar. Okay, you can do it. Believe in yourself. All you gotta do is try. Yeah. I'm pretty sure silly dances make me remember things better, so maybe you guys should just try it. Alright. What do you guys think this means? I know it's tough sometimes to decipher all the code words in this thing, but the idea is this. It's fairly straightforward. If I have a triangle and another triangle, and I say that this angle is congruent to this angle, and then I have side A and side B. And I say this is A1 and this is B1 and this is A2 and this is B2. Okay? Do you understand? It's A on the first triangle, B on the first triangle, A on the second triangle, B on the second triangle, right? Okay? If A1 over A2, or vice versa, is equal to B1 over B2, then the triangles are similar. Triangle 1 is similar to triangle 2. Okay? What does this mean? It means that the multiplying factor is the same, right? If this is twice as big as this, then this is twice as big as that. Okay? The ratio between the sides is the same. Or the ratios between the two sets of sides are the same. Okay.
Okay.
He couldn't even explain it. I said, what? Why? I don't know. It's too savage, apparently. Does that make sense to you?
Yes.
Relatively, maybe. Now, do you remember side angle side? There was a side angle side. What did we have? Side angle side proved that two triangles are congruent, right? We had the side angle side congruence theorem, right? This is the side angle side similarity theorem. So the difference is these two angles are congruent, but these two sides, they're proportional. Two sets of sides are proportional, right? But if I had said that they were congruent, then I would have known that the third side had to be congruent, right? Because of the side angle side congruency theorem. Well, the same kind of logic applies here, where if this side is proportional to this side, same ratios, then if I have a C1 and a C2, then that would equal the same ratio. That these would also be similar. So A1 over A2 would also equal C1 over C2. Instead of saying that they were congruent because the sides are congruent, clearly those sides aren't congruent, right? But because I know that they're proportional, right, then that same multiplying factor must apply to the third side as well. And you might be able to see that, right? Because if I'm multiplying this one by the same amount as this one, right, I'm just going to keep spreading out in this direction. If I keep spreading out in this direction, well, always with the same multiplying factor, then this side is going to keep growing at the same multiplying factor as both of those sides. Does that make sense? Does that make sense? So that's the basic idea there, okay? That if the two sides are proportional, two sets of sides have the same ratio, then the third set of sides will also have the same ratio. Okay? Plain and simple. Got it? Yeah. Okay. Cool, right? Let's see. Could give you something like this. And now it's difficult for me to ask you to specifically write a proof that these are similar. But can somebody tell me why they're similar? Yes?
Because there's two sides.
Let's call this, just to make it easy for you to talk about it, let's call this side A, it's 2, this is side B, it's 4, this is side C, is 8. Why?
As far as I got, it was side A was going to the side B. I mean, it's similar to it. And 4 is going to C. I mean, similar.
Right. So if I look at this triangle, this side of this triangle is what? 4, and this is 2, right? So this is twice as long as this. And then if this is that side, right? Well, that's twice as long as that, right? So they're both multiplied by the same multiplying factor, is that right? And I know that the angle in between the two sides is congruent. So therefore the two triangles are similar. Right. Very good. Very good indeed. What? So, if I were to give you types of questions like this, and you'll see it in the homework, I'm really not so much going to be asking you to write out a formal proof of it, as much as I'm going to ask you to just tell me why. And you would say, well, either the angle-angle similarity postulate or the side-angle-side similarity theorem. Right? Does that make sense? You'll see it in the homework. That's how it is. They'll say, explain why the triangles are similar. When they say explain why, they just mean right angle-angle similarity or side-angle-side similarity postulate theorem. Understood? Yeah? Maybe? Let me dance to it. All right, that's enough. All right, side similarity. Last one. Last one. Actually, you know what? Oh wait, we do have 10 minutes. But we only have 5. The last one, I promise. Theorem 7.2. Side similarity theorem. Side similarity theorem. We already know this. You guys don't need to know this. You guys know this. This is a silly one. You already know this one. This is the definition of it. This is silly, but I'm just gonna give it to you anyway because it's in your book. What do you think this is?
All sides are
If all sides are not congruent, proportional is the word we use, then the triangle is. That's the definition of a similar triangle, right? If all sides of a triangle are proportional, then of two triangles, I should say. If all sides of two triangles are proportional, I apologize. Two triangles are proportional, then the triangles are similar. Okay. Did you want me to do one of the questions? Which one do you remember? No, maybe. It was on. Was it measure the map distance?
No, it's 25.
25. You want to make a scale drawing? That's it. I don't think we need to show this. We've done this
Alright.
with. But I'm gonna do number 25 for you now. But that's it for your new notes. Let's do this homework problem. 25 on page 369. Obviously, you don't have to write this down, but it is one of your homework problems, so it will benefit you, probably. You want to make a scale drawing of your bedroom to help you arrange your furniture. You decide on a scale of 3 inches equals 2 feet. By the way, this is what's done in maps and globes all the time. You have to scale a map. Obviously, if you made a map being the size of the entire state of Florida, it would just be the state of Florida. And it wouldn't be a map. It would just be a state. Your bedroom is a 12-foot by 15-foot triangle. What should be its dimensions in your scale drawing?
Triangle.
Rectangle. Your bedroom is a 12 by 15-foot rectangle. What should the dimensions be of your drawing? Okay. So here is what you do. The ratio here is 3 inches over 2 feet. Right? For every 3 inches, you have 2 feet. For every 2 feet, you have 3 inches in your drawing, right? In order to figure out how many inches, all you have to do, who thinks what I should do? Well, let's see, I have feet on the bottom here. This is in feet, and this is in feet. What should I do to get the number of inches? Well, if I have 3 inches for every 2 feet, how many inches should I have for 12 feet?
Oh,
It's 18.
What's my multiplying factor?
You divide by 2 and multiply.
What's my multiplying factor between 2 and 12? 6. So this should be what? 3 times 6, which is 18 inches. What's my multiplying factor here between 2 and 15? 7.5. 7 times 3 is 0.5 times 3 is half of 3 is 1.5. 21 plus 1.5 is. There you go. You could also do it, class. You could also just do this. Look, multiply by 12. You can multiply by 12. Same thing. So we were doing the exact same thing. Because what were we doing to get the multiplying factor? We were doing 12 divided by 2. We found that was 6, then we multiplied it by 3. Same thing here. Or we could have done 3 inches over 2 feet times 15 feet. Now, what about if I said, I've got a scale drawing of my bedroom, and it's 4 inches, different bedroom, by 7 inches. Same scale though, 3 inches to 2 feet. Right? Well, what I would want to do is write my ratio such that my inches is on the top or the bottom? On bottom. Why? 2 feet over 3 inches. Why? So I can cross it out, right? So if I multiply by 4 inches, I'm not going to do math here. I